Section 11.6, adding and subtracting rational expressions, page 712. The first part of this is relatively easy. The latter part gets a little tricky. So you know that in order to add fractions, they have to have a common denominator. Same thing in order to subtract fractions, they have to have a common denominator. A over C plus B over C have a common denominator of C, so you can add, the numerator becomes A plus B all divided by C. Not C plus C, don't do that, all right? You know that 1/2 plus 1/2 equals 2/2, which is, all right? So 1/2 plus 1/2 equals 2. So 1 over 2 plus 1 over 2 equals 2 over 2. The denominator is common, all right? Same thing with subtraction. A over C minus B over C equals A minus B over C. We're going to see the same thing here. The first part, we have common denominators, which is really nice. So they have a common denominator of n plus 3. So we're going to add 5n plus 15 all over n plus 3. All right, that's our common denominator. Now this does simplify because this, I can factor out a 5 here. So I get 5n plus 3 all over n plus 3. Okay, so because that's 5 times n is 5n, 5 times 3 is 15. And n plus 3 cancels, and that becomes 5. Subtracting is very much the same, except there is just one little thing you have to be careful with. So 3m minus 5 all over n plus 4 minus 4n plus 2 all over n plus 4. They have a common denominator of n plus 4. So we can subtract 3m minus 5. Use parentheses. Subtraction has something you be very careful with, all right? I would use parentheses here all over the common denominator of n plus 4. And the reason why, remember, this negative sign applies to both of those up here, all right? Common denominator. So I'm going to end up with, now I can get rid of my parentheses, 3m minus 5 minus 4m, and this is the part that people mess up on all the time. It's not, don't forget that negative sign applies to everything in the parentheses. Minus 4m minus 2. That's the biggest issue, is that negative 2. All divided by m plus 4. Let's see, combine any like terms. So that's going to be 3 minus 4 is going to be negative m. Minus 7 all over m plus 4. And we're done. Next one. Is 3n all over n minus 4 plus 6n divided by 4 minus n. This is an inverse denominator. N minus 4 versus 4 minus n. We did something like this in a previous section where if we factor out a negative sign and put parentheses around the negative sign out here, then we can switch these around to get. So let's just go ahead and do it. So the first part is going to be 3n minus n minus 4 plus 6. I'm going to use parentheses here, and I'm going to factor out a negative sign to the side, and that becomes n minus 4. Just in case you don't believe me, again, if I brought that negative sign back in, I'd get negative n, which is that, and negative times negative 4 is positive 4. Okay, so this is not, the reason why we did that is now that I have a common denominator of n minus 4 and n minus 4. This negative sign applies to the whole fraction. So let's just rewrite that. So that's 3n all over n minus 4. This applies to everything, so I can put it right here, minus 6n minus 4. And now I've got a common denominator, so that's going to be 3n minus 6 all over n minus 4. And I think there's really not much else we can do with that. Well, yeah, there is. I'm sorry. Wait, did I make a mistake? No, whoops. I did make a mistake in my rush. There's an n up here in the example. Let me just tell you. My answer was correct the way I wrote it, but I wrote it wrong. If you're looking at the example in the book, it was 3n plus 6n. And here's the denominator. The main point of it, so here's my 3n plus 6n. I still had to change this, factored out the negative sign so that we have a common denominator. That negative sign is now right here. And now we can do 3n minus 6n, which becomes, you see I can factor out, well, what is 3n minus 6n? So 3n minus 6n is negative 3n all over n minus 4. 3 minus 6 is negative 3, right? 3 minus 6 is negative 3. So, and I think that's the final answer. Yeah. Alrighty, so this next part, how am I doing in time? I have enough time. So the next thing is what happens when the denominators are not common? This is a little tricky. We need to find the lowest common denominator, the LCD, the lowest common denominator. The lowest common denominator is the same thing as what's called the lowest common multiple. So the first thing, we're going to look at adding and subtracting unlike denominators. So the first thing is finding the least common multiple. The least common multiple. That is the LCM, which is basically what you do when you find lowest common denominators. Okay. So the first step here is we're going to find the LCM between two things. I'm on page 713. Let's find the LCM between 6x and 4x cubed. So the first thing is write these things in their prime factor expression. So prime factor is, okay, 6 is 2 times 3 times x. 4x cubed is 2 times 2 times x times x times x. That's prime factorization. The least common multiple is find every factor and write down the most number of times a factor occurs. I didn't say that very well, but let's take the number 2. Number 2 occurs once here, it occurs twice here. Take the biggest one. And so that's going to be 2 times 2. Take that, there's a 2 here, but there's 2 of them here. So I'm going to use those 2. There's a 3. Take the greatest number of each factor. So that 3 is right here. That one doesn't have one. It's okay. If this thing were 3 and that were like 3 times 3, I'd have put 3 times 3. But so write down the greatest number of times this it appears in either of the factorizations. The greatest number of times 2 appears in either of the factorizations is twice. The greatest number of times 3 appears in either of the factorizations is that 1. The greatest number of times that x appears is this one, all right? So that's x times x times x. So now we can write this out as 2 times 2 is 4 times 3 is 12. 4 times 3 is 12, x cubed. That is the LCM, the least common multiple for this, all right? They do this with a polynomial. I'm kind of rushing through this because they're going to kick me off campus here fairly soon. N squared plus 5n plus 4 and n plus 1 squared. Okay, well, let's factor these things. This is going to be 4 times 1, and so 4 and 1. So this is going to be n plus 4. I'll write it this way, it doesn't really matter. N plus 1, n plus 4. I think that's right. Yeah, that's the factors of that. And this, of course, is n plus 1, n plus 1, n plus 1 squared. So the least common multiple, remember you find each factor, and when does it occur the greatest number of times? Well, this is n plus 1 plus n plus 1, okay? And then the most number of times it occurs. And in either one, so that occurs twice there. And this one occurs once over here. That would be your least common multiple. Okay, which the only way you would simplify this is n plus 1 squared, n plus 4. That's not really all that important in this lesson. Okay, here's where this comes into use. It's the LCM is the lowest common denominator. So let's look at this example on page 714. If we have 3t plus 2 all over t squared minus 2t minus 3 plus t plus 1 all over t minus 3. Let's factor this one, which is going to be 3t plus 2 all over t minus 3, t plus 1. All right, that's the factors of the denominator. All right, yeah, that works. Plus t plus 1 all over t minus 3. Well, okay, the lowest common multiple, I'm looking at the denominator because I'm looking for a lowest common denominator. Remember the prime factorizations, I've got t minus 3 and t plus 1, t minus 3. So what's the lowest common multiple? The lowest common multiple is remember, when these factors occur the most times in either one, well, t minus 3 just occurs once. And then this occurs once. And so your lowest common multiple is the lowest common denominator. So the LCM is the LCD, lowest common denominator, which would be t minus 3 and t plus 1. Okay, so what we need to do here is multiply this by t plus 1 and t plus 1 to get the common denominator. Unfortunately, I'm going to have to stop this, and I'll pick it up on the next video.